So this text set revolves around reflections, which is another type of transformations, which is a subject that I have been sort of unraveling and diving into a little bit during this entire institute. So I thought I'd keep true to the theme of transformations and work with something a little more visual for my text set. Okay, so I'm going to analyze first the text from the book, which looks a little something like this. We have section 9.3, perform reflections. Just to focus on this blue page here. They lay out some key concepts here, then some mathematical terms, and then they move down the page and do a few examples over random lines of symmetry. Then if we flip a page, I'm only going to focus on the first two pages because there's just so much in this book, in this particular section. Then it goes into actually graphing, and then if you see this blue box in the middle here, the key concepts, specifically it says for your notebook over there, hang on, I can't get the camera, for your notebook, underneath the rules. I'm going to focus on that a lot during this lesson. And then also it goes into some more examples over different lines of reflection. So I'm going to begin kind of going through this first text here rapidly. And instead of doing first from the perspective as a part of this particular discourse community, I'm going to kind of do them both at the same time from the perspective of the student and the teacher. Because I felt last time during my Think Aloud, it was really hard to kind of like separate them because I have been the student and I have been part of this particular discourse community also. So I'm going to do them both at the same time. I think that will be more beneficial for me, at least for my paper, from the standpoint of the paper. Okay, so the book begins by first laying out the standard, the particular New York State standard that goes with this section in particular. It says what we did before concerning reflections. We reflected a figure on the x or the y-axis. I don't really know what that means. From the standpoint of the student or from the standpoint of the teacher, I think, I mean, it seems a little ambiguous. I reflected a figure in the x or the y-axis. I don't know if that means I did that mathematically, if I did that visually, if I used a manipulative to do that. I don't really know what that means. So it says now we're going to reflect a figure in any given line. Okay, I don't really know what that means either, from either standpoint. And then it says why, so you can identify reflections. Okay, so basically the goal here is we're going to identify what is a reflection and what is not a reflection. It goes through some mathematical jargon here, which is a little bit difficult to understand. I do like this explanation here. It uses this explanation uses very much layman's terms to explain the math, which I like. It says, in lesson 4.8, you learned that a reflection is a transformation that uses a line like a mirror to reflect an image. The mirror line is called the line of reflection. So for me, at least, from both the teacher standpoint and the student standpoint, that's very clear. It's a transformation, which the students should know at this point what a transformation means, what that word means, what a transformation really is. And you use a line like a mirror to reflect an image. That's something that's very familiar to most students, I would assume, in the high school level. Everyone's looked in a mirror before. They've seen their own reflection. They've seen that it's basically the same thing, it's just opposite. And obviously the mirror is the thing that reflects the image. So then it goes into mathematical language. A reflection in a line M maps every point P in the plane to a point P prime so that for each point one of the following properties is true, and then it lists two properties. There's a lot going on there. I completely understand that from the perspective of the teacher. Absolutely, no question. I think that, it's very clear they're labeling M as the line. The word maps every point. M maps every point. Do they know what the word maps means? Do they understand that that's a verb? We're using that as a verb here, and maps means places every point P onto the point P prime. I don't really know. I think it's ambiguous. I think that this is an example of textbook jargon that is just assumed to be known, whereas, I believe that it's important to, we don't want to reinvent the wheel every time we write something in a textbook, but I do think that there is value to explaining mathematical vocabulary that isn't in a yellow highlight. I think, I don't know, maybe I'm wrong. Maybe there's somewhere in this textbook that I haven't been able to find, which, I did search, that explains what the process maps onto means. But I haven't been able to find it, and I doubt the students have ever been taught that explicitly. So, I don't know. I think this is an example. I'm sure this happens in other textbooks too, but I think especially this happens in math, where they just expect to know this vernacular of this vocabulary of mathematics, of the action of doing mathematics, that it just, a lot is assumed. A lot is assumed in this little paragraph here. I'm going to go ahead and skip down to go through some guided practice. I'm going to go ahead and skip down to that blue box that I described earlier, the key concepts, and it specifically, explicitly states for your notebook. So because, at least in my opinion, because there's a little spiral notebook in the middle of this page, it specifically says for your notebook, and it has key concept written in bold at the top. I'll show a visual of that again. This blue box here. Yes, it highlights the rules that we're supposed to learn for reflections, but because it's highlighting that, it's sort of like, does all the other stuff on the page really matter? At least from the perspective of the student, if I were the student, I would ignore everything on these 2 pages, and I would look at this piece of this text, and I would pop it in my notebook and not understand a thing. So I do think that it's helpful to have these rules explicitly written out in very clear, concise mathematical language. If point A, comma B is reflected in the x-axis, its image is the point A, comma negative B, period. That's one coordinate rule for reflection, and then it goes through 3 other rules. There's a lot that is assumed here. It's assuming that, the student knows where the x-axis is. It's assuming that the student knows that a point being reflected over the x-axis becomes an image. Well, what's an image? We don't, I do believe it was explained in the section before on translations, which is another type of transformation. But, again, we don't want to reinvent the wheel every time we do text, every time we build upon a text, but this is very specific vocabulary to transformations. I think it should be more explicit from the perspective of the student. As the teacher, of course I know what an image is, and I'm sure, you, Vaughn, as an English teacher, can read the word image and understand what an image is. An image is a projection of something. But from a mathematical standpoint, does the student really know what an image is? An image